Hi everyone. In this video we will be talking about rational equations. Okay, so we have talked about rational expressions and we have seen how their addition subtraction works using the least common denominator method. Let's do a quick recap. So for example, if I have to add these expressions, I try to find the least common denominator for these is 6x. So to get a 6x in the first one, I multiply divide by 3, and to get a 6x in the second one, I multiply divide by 2. When I do that, I get 3x plus 12 over 6x plus 2x plus 40 over 6x. And now, since the denominators are the same, I can combine them, and the 3x and the 2x give me a 5x, and the 12 and 40 give me a 52. So that would be the simplified form of the addition of these rational expressions. Now suppose we go a step further and we ask for what values of x does, this is the same expression as before, equal 3. So the step 1 is always going to be to simplify, which we have already done. So 5x plus 52 over 6x equals 3. And then we cross multiply and solve. I guess we can call that step 2. So cross multiplying gives me 5x plus 52 equals 3 times 6, which is 18x. Subtract 5x gives me 13x equals 52. Then divide by 13 gives me x is 4. Which means that this particular rational expression, for this to equal 3, x has to equal 4. And now we have one small thing that we need to do, which is verify. Verify that 4 plus 4 over 2 times 4 plus 4 plus 20 over 4, that's 8 over 8 plus 24 over 4, which is 1 plus 6, which is 7. So there's something wrong there. It should be 3, but it is coming out to be 7. Let me check. 3x plus 12, 2x plus 40, 2 plus 3, 5x, 40 plus 12, 52. And it is the same problem. It equals 3. Gives me 18x. Subtract 5. 18 minus 5 is 13. 13x equals 52. Divide by 13. 13 goes into 52 4 times, giving me x is 4. I see where I went wrong. So this is 3 times 4, right? So this is a 12. So it's actually 1 plus 2, which is 3, which means it is correct. So again, just make sure that you also verify your result in order to make sure that it makes sense. Okay. The second example here, there are more than one ways of doing this. You can either so here are the different ways of working on it. You can either subtract and then simplify and then solve, or you can multiply both sides by the LCD, and then lastly you can just cross multiply. Okay, so let me show you how that works. So let's do the second one. The LCD here is x plus 10 times x plus 4, because basically you take all possible factors, right? So if I multiply by that, it's going to look like x plus 10 times x plus 4 times x plus 1 over x plus 10 equals x minus 2 over x plus 4 times x plus 10 times x plus 4. X plus 10 cancels out, x plus 4 cancels out. And you're left with this equation that you can solve. So we FOIL out to get x squared plus x plus 4x plus 4 equals x squared plus 10x minus 2x minus 20. So that is x squared plus 5x plus 4 equals x squared plus 8x minus 20. Now we collect everything on one side, so I subtract x squared minus 8x plus 20 minus x squared minus 8x plus 20. When I do that, the x squared terms get cancelled. 5x minus 8x is negative 3x plus 24 equals 0, which means 3x equals 24 or x equals 8. Now once you have that, we have to do our little verification here. So if x is 8, then I have 8 plus 1 over 8 plus 10 is 9 over 18 is 1/2. And then 8 minus 2 over 8 plus 4 is 6 over 12 is 1/2. So they match up, which means the solution is okay. Now, if you cross multiply, you end up exactly here, right? So it just saves you the step of multiplying by the LCD, but it is exactly the same thing. Now, let's look at this example. Now, over here, there's a number involved, but what I also notice is that these denominators are the same, right? So denominators are same, which means that if my denominators are same, I know that I can combine these things. If I can combine them, then this is just x over x minus 3 minus 3 over x minus 3 is 9, which is x minus 3 over x minus 3 equals 9, but these cancel out, which says 1 equals 9, which is definitely not true. Now we have encountered these kind of things before. When we get an absurd equation from solving, that means basically that there is no solution. Which is to say that this particular equation involving rational expressions cannot take this value 9, because it's actually 1, and 1 cannot be made equal to 9. So recall in systems of equation 2, when we end up with something absurd like 1 equals 0 or something like that, then the interpretation of that is that there is no solution. So same here. If you end up with an absurd statement, then the interpretation is that there is no solution. Let's look at another example. This says x over 2 plus 2 over x equals 5. So I quickly find the LCD to be 2x. So I multiply 2x by x over 2, 2x by 12 over x, and 5 by 2x. When I do that, the 2's cancel, x's cancel. What I'm left with is x squared plus 24 equals 10x, which then becomes x squared minus 10x plus 24 equals 0, which we know from our factoring that I can split this as negative 6x minus 4x plus 24, giving me x minus 6 minus 4x minus 6. X minus 4 times x minus 6 equals 0, or x equals 4 and x equals 6. But again, do not forget to verify. 4 over 2 plus 12 over 4 is 2 plus 3, which is 5. And 6 over 2 plus 12 over 6 is 3 plus 2, which is also 5. Therefore, both of these solutions make sense. A last example here, which is slight bit more complicated. Now in this case, just to make sure that things might be simpler than they actually seem, I'm going to factor this denominator. To factor this, I split them as negative 3, negative 4, which comes out to x times x minus 4 minus 3 times x minus 4, which comes out to x minus 3 times x minus 4. Which is good news, because those are exactly the factors I have there, which means my LCD is simply x minus 3 times x minus 4. So I multiply by, so I can multiply by the LCD, and I have x minus 3 times x minus 4 times 3 over x minus 3 plus x minus 3 times x minus 4 times 5 over x minus 4 equals x minus 3, x minus 4, x squared minus 20 over x minus 3 times x minus 4, because that is what the factoring of that polynomial is. Now we cancel out what we can, cancel out what we can, cancel out all of that. The next step, as in previous examples, is foiling. 3x minus 12 plus 5x minus 15 equals x squared minus 20. So I have 8x minus 27 equals x squared minus 20. So let's collect everything to one side. Negative 8x plus 27. When we collect everything to one side, this ends up being x squared minus 8x. 27 minus 20 is 7 equals 0, which then factors as negative 7, negative 1 to get x, x minus 7 minus 1, x minus 7, which becomes x minus 1 times x minus 7, which gives me two results, namely x is 1 or x is 7. Now once again, we do need to verify. Okay, so in this case, the verification, I'm going to copy the question here so I can actually verify it. This is the expression we're trying to verify. Okay, so 3 over 1 minus 3 plus 5 over 1 minus 4, that's negative 3 over 2 plus 5 over negative 3, which is negative 6, 9 plus 10, or negative 19 over 6. 1 squared minus 20, that's negative 19. And then 1 squared minus 7 plus 12 is 6. So this is negative 19 over 6. They match up. With 7, it's 3 over 7 minus 3 plus 5 over 7 minus 4, which is 3 over 4 plus 5 over 3, that's 12. 3 times 3 is 9, plus 4 times 5 is 20. So this is 29 over 12. And on this side, this is 7 squared minus 20. It's 49 minus 20 is 29. Then 7 squared minus 7 times 7 plus 12. The first two terms cancel out because that's 7 squared minus 7 squared. So it is 29 over 12, which also matches up. So we say that the solution is x equals 1 or x equals 4. Okay, so that brings us to the end of this week's material. So the last thing that we did here is equations which involve rational expressions and how to solve them. The technique remains the same in the sense that we still use the lowest common denominators in order to solve these equations. Okay, that's it for this week. Thank you.